10-minute micro.
Hi everyone, it's time for a 10-minute micro where I'm going to spend 10 minutes looking for the first time at a slide, and I'm going to watch it with you. Let's start by taking a look at this root from a floating plant at a nearby fishing pond. And as you can see, it's absolutely covered with peritrichs and rotifers. And as I scan around, I'll be adding arrows to point out kind of what we're looking at and what I'm mentioning. But here right in the middle is a group of peritrichs that's colonial. You can see that the stalks that they're attached to, these are ciliates, but the stalks that they're attached to branch out from each other. And that's a sign that these are colonial. On the other hand, if you look at this huge mass of peritrichs that are kind of golden and white in the middle now, these seem to be more of the non-colonial independent type, probably vorticella or something similar. Each stalk is attached to the branch on its own, and while they might get twisted and tangled, they're still non-colonial. We see a lot of rotifers that have eggs attached to them, and let's see if I can get a nice view right in the middle now. I'll put an arrow on there. I don't know what kind of rotifer this is, but you can see it's attached with its toe, its foot, and it really thrashes around, and toward the back end you can see an egg attached to it. It seems that there are a lot of those with eggs in this sample that I took, which means it's probably a very healthy, nutritious environment. I'm sure you'll be seeing more of them like that as we look around. So here, a lot more rotifers and peritrichs. That seems to be the nature of what we're looking at today. But let's see if we can find some other interesting stuff. Wow. This is a rotifer called Collotheca, and it happens to be my absolute favorite rotifer. I'm going to zoom in a little bit, and you'll see it's upside down, facing downward. You see these, it looks like 4, but it may be 5 lobes in blue down at the bottom of the screen. And there are hairs attached. These are cilia. And these cilia are used, they're retracted, and now it's coming back up. But these cilia slowly vibrate very, very subtly in the water. And what they do is they attract single-cell organisms. There's one going in right now. You can see it right flank, and it's going to get swallowed. It just got swallowed by the Collotheca. So this is how they attract their prey and they eat. Ooh, it just did it again. It's got a bunch of eggs, as you can see, toward the back of its tube that it lives in, its lorica. And that's pretty amazing. That's a big one. Very beautiful. Let's zoom back out and cut the light back down a little bit and keep looking. Let's cut that light down a little bit more. There's an air bubble up top. You can ignore that. Okay, there's an air bubble. Let's get past that and go to the next root. Next piece of root. So there's a good example of a rotifer with multiple eggs attached to it. Absolutely beautiful, and it looks like they're reproducing very nicely. Rotifers are not single-cell organisms. They're microanimals, and each of them contain usually about 1,000 cells. These peritrichs, like this cluster of what I'm assuming is vorticella that you see here, these are single-cell ciliate organisms. They have rows of cilia that you can see beating and twisting and causing a current inside the water column, which, because of all these little white particles that you see, you can actually see them attracting food into them, into their open ends, which allows them to feed. Let's look over here. Oh, we got a worm, or part of a worm. Here's another cluster of, let's cut the light down a little bit, rotifers with eggs. Ooh, there's another beautiful Collotheca off to the left. And I love when I found there's another Collotheca. They're all over the place. This is just loaded. Oh my Lord, look how beautiful this one is. Okay, I'm gonna show you, let's see how much. We've got about 4.5 minutes left. I've got time. Give me a moment and I'm gonna quickly try to switch to a different type of lighting. 1, 2, 3. Bear with me. Bear with me. Uh-oh, I don't know if this is gonna work. Okay, it did. So now we're looking at a type of lighting called phase contrast. And this allows a different type of look at the organism. We're zoomed way in, and now you can see the coronal lobes that I mentioned. Here you can see 3 of them in focus. If I switch focus to the back, I see 2 more. So it looks like there are 5 lobes, and each lobe is covered with these hairs. Absolutely beautiful. And the reason that it's kind of shifting around is because the water column under the slide, I've added a lot of water. It's pretty thick. And so anything that's moving anywhere near it, like other rotifers that are flopping around, that's what's causing it to move around. We're down to 3.5 minutes, so let's go back out. Just give me a moment to get back out and put our dark field filter back on and get back here. Okay, so what did I do? There we go. So now we're back in dark field, wide angle. And oh, this is just such an active scene. Look at the amount of life. Now, just to give you an idea, from left to right, as we're scanning across this piece of root from a plant, on the slide, it's about, I'd say, 3 centimeters at the most, 2.5 to 3 centimeters of a piece of root. And this is the amount of life on just that small amount of root. This right in the middle is the rear end, ooh, it just pooped, of a worm, some type of a darrow worm. And the back end is actually more interesting to look at than the front end on those worms. I'm not a huge worm fan, but darrow worms happen to be kind of interesting to look at. There's a big worm. You can see an annelid, and you can see the setae, the hairs, fibers sticking out from each side to kind of delineate where each segment of the worm is. We're down to about 2 minutes left. These 10-minute looks go pretty quickly. But God, it's just so overwhelming, the amount of life that we see. Absolutely amazing. So these single-cell peritrichs, the reason there are so many is because they're in a nutrient-rich environment at the fishing pond. And at that fishing pond, they're undergoing binary fission regularly over and over again. And they just keep going and going and going. And 1 turns to 2, turns to 4, turns to 8. And as long as the nutrients are there to support it, we're in the middle of the rainy season here in Thailand. And what that means is that nutrients are being constantly washed into the water. And this is, like I mentioned, a fishing pond not too far from me, which is already kind of a nutritious habitat for fish. And you add in the rainy season, and it's just phenomenal. You can see more Collotheca. There's one on the right with a couple of eggs. There's one on the left. So as we near the end of there are 3 on the left. As we near the end of our time, our 10 minutes, I just want to thank you for coming to watch this. I do these 10-minute micros pretty often, so I hope that if you enjoy this, to see the kind of life that we find in our local waterways, you subscribe and get notified as to when I'm putting these out. Thanks again. Have a good day. Thanks for joining us on today's look inside the microcosmos. We hope you'll consider subscribing to our channel so you won't miss our next adventure.